Hello and welcome to our safety and security webinar today. My name is Nikki Rousseau. I'm the CEO of Robotics Australia Group. Thank you very much for making time available to be here with us today. Dr. Nathan Kirchner, who is the founding director and current board member of Robotics Australia Group, will be the moderator for our panel today, and I'm going to hand over to him. But before I do, thank you very much to Craig, Kerry, and David for being here and being available to chat to us today. Thanks, Nathan. Over to you.
Cheers, Nikki. So just as a refresher to everyone, so Robotics Australia is really about representing the robotics community, the efforts in the country. The reality is we have these deep pockets of excellence. We do some pretty amazing things. If we could connect those together, maybe inform each other so we know what's going on, inform the government, inform the companies around us, inform the potential buyers that's happening, advocate so that government, the companies, the communities know that we've got some homegrown excellence, and promote, which is really just generate awareness and make sure everyone sees it. Then we can achieve more as a country. Probably, and better said, we can start to build the conduits we need for the excellence we already have to be making its way into deeper use. Right, moving on. So lots of people watch these webinars, which is cool. Quite a few participate on the spot, and even more jump on their videos afterwards to watch it. So we're getting quite a legacy going here, which is awesome. So without further ado, today we have a couple of amazing people joining us. Let me go through them one by one. So Kerry is a business developer, manager officer at Universal Field Robotics. He really is in charge of bridging a gap between the customers and the needs and potential robotics technology. So you see how that's connected in. Likes to build partnerships, and he's going to introduce himself fully in a second. So don't worry too much about my chunky job of it. This talk's really going to be about the pivotal role of robotics in shaping the future of safety and innovation in mining in particular. You explore certain things like how robotics drive safer operations, unlock hidden value, set new standards. And of course, he's going to be giving some Universal Field Robotics projects as examples to build the discussion on. So that's pretty cool. Dr. David Cole. So David's a co-founder and CEO of FlyFreely, drone management software platform used by enterprises around the world to manage their drone operations, their compliance and their fleet, obviously. So I think there's some good parallels there. His talk's going to be largely about drones themselves and how they're used to reduce safety and security risks, but also go into the methods that have been developed to quantify and mitigate safety and security and extrapolate that out to methods that can be developed for other applications, land, water, and of course into autonomy. And then to close things off, we're going to be hearing from Craig. So Craig's a senior safety consultant at PILZ Automation. So he's really into the consulting and training services for customers in machine safety. It's quite a complex and rich space. So it's one thing to have these ideas, it's another thing to get them to do something, but it's a whole nother level of complexity to actually build that into business as usual for a company and a system that the workforce can exist around. So I won't tread too much on Craig's toes. I'm sure we'll get there and you'll see what I mean. But I think it's time for me to stop talking. So I'll hand over to David right now, and he can tell us all about it. Thanks, David. Over to you, mate.
Awesome. Thanks, Nathan. Yeah. Hello, everybody. My name's David Cole. I'm the co-founder and CEO of FlyFreely. My background is I'm a mechanical and structural engineer. And really got into so not a mechatronics or aerospace engineer, but really got interested in the whole drones industry back in 2013 when I was working as a consulting engineer, seeing a lot of different problems in industry which I thought could be solved using the flying drones. So yeah, we basically got involved in the industry back then and sort of been involved in it since.
Cool. Kerry, do you want to give us a couple of minutes on you?
Sure. Hi, everyone. I'm Kerry Doherty from Universal Field Robots. My role there officially is Business Development and Sales Officer. but I started here. My background is in law. So I started here 3 years ago, came on board to sort of review intellectual property, workplace safety, and then have sort of spread more and more into the customer engagement side. So a big part of what I do at UFR is really around the maintenance and compliance part with rolling our products out, specifically into mines. So I spend a lot of time talking to mines and their representatives, understanding what the challenges are, what their desires are for robotics, and how we can sort of fit in amongst that and develop their thinking along the way as well. So this is my first time being part of a Robotics Australia group event. I'm very excited. It was only 3 years ago that I was sitting down watching this very sort of, in the reverse position, just as a participant. So back then, as a former lawyer, the acronyms really made my head spin. It's taken me a little while to get back up to to get up to speed. And even though I'm not proficient in the robotics nomenclature,
and law's really accessible to all the rest of us, just by the way.
Yes, that's right. I've spent a lot of time trying to break that down, put it into a easy to understand way, and hopefully bridge that gap a little bit between what is possible and what I'm seeing from our very talented engineers, and then being able to translate that into real life. So very excited to be here, very excited to share what's going on in Brisbane and Queensland and across Australia. So hopefully I can sprinkle in a healthy amount of acronyms to keep everyone on their toes throughout my presentation.
Cool. Let me force us all to take a giant step back. I'll go first. So something like 10, 20, 30 times the number of people who can make it to the live event ends up watching what we're talking about on YouTube. So just let everyone know that. So it does have a bit of reach. We haven't quite got to the population of China yet, but we're on the way. Second is, you guys do some really cool stuff. So the drone management software, UFR, automate, this and that, blast dog, that golf buggy thing in the mines. Just wheel it back, tell everyone about some of the cool products you actually make, and let's start there. And we'll I don't know, someone will edit this in so that was a seamless intro.
Yeah, okay. I mean, I can, yeah, I've got that as part of my presentation, but happy to sort of elaborate now. So I guess from a FlyFreely perspective, what we've focused in on is actually building software tools to help automate the management of drone operations, the compliance and the maintenance side. So we spend a lot of our time, understanding regulations, and a lot of the new developments that are happening are around airspace integration. So how do the flying drones integrate in with other aircraft and those systems? And now even more recently, it's kind of the drone in the box type applications where you start remotely controlling the drone, fully remotely, and all the challenges that brings with it. So yeah, that's sort of in a nutshell, sort of the areas we're focused on.
Cool. And Kerry, you want to tell us about some of the big yellow stuff? Oh, sorry, Dave.
I was just going to say, I'll go through what some of our customers, because I think what's interesting is what our customers do. So I'll go through some of those in the presentation.
Cool.
All right. So Universal Field Robots started 7 years ago. Very small startup company. The goal there was to take dumb machines that operate in dirty, dangerous, dull environments and give them automation smarts. So there's a lot of retrofitting, but we also do a large amount of prototype development. And our core customers end up being the mining industry, construction, defense and agriculture. Mining plays a massive.
It's hard to believe you find dirty, dull, and dangerous in mining or construction.
Yes. So mining plays a huge part in sort of the development of where we're going at the moment. Obviously, they've got some deep pockets, but more than that, they've got a really burning need Safety is an enormous issue, and that's going to be something, the main point of what we're talking about today is around, well, what I'll be talking today is around how robotics plays a massive part in safety, and especially within the mining industry.
Yep. Okay, with that, because I don't want to spoil everything, and if I don't like your presentation, I'm going to interrupt and prompt you to talk about something. But anyway, do you want to start, David? Do you want to start with the preso?
Yeah, just disabled. I need to enable screen sharing.
Yes, Nikki, you're on mute if you're trying to pass us a message.
Jane, can you just disable David's video, his presentation?
Enable screen sharing.
Enable, yeah. She knows what I'm trying to say.
Awesome. In the meantime, how about that sport?
There has been some cracking sport recently. Brisbane has been the place for it.
Oh, I haven't heard good things about Brisbane, mate. I don't know about that.
It's I'm reaching my limits here at the moment. It's hard to pick between 40 degrees and humid and cyclones, but
move to Sydney right now. You don't have to pick. We've got 40 degrees and humid as well.
we've got it all sorted.
Awesome.
Best place in the world.
That's all appearing.
Cool.
Cool. Yeah, well, thanks everybody. Thanks again for the invitation and opportunity to talk today. And sort of as we've seen in the intros, our really interest in robots is of the flying variety. So that's what I'll be sort of focused in on today, and sort of coming at this from a couple of angles. So I'll quickly just start off a little bit about our journey. So as I sort of mentioned, we started off as a commercial drone services provider back in 2013. So doing a lot of work for the mining, construction, ag markets. Then in 2018, we actually started developing our own software platform to help us manage our own operations. We then had people coming to us and saying, hey, we like that, can we use it? So we then pivoted the company away from providing services into building software. Since then, in 2021, we were verified by CASA and approved to provide automated airspace authorizations in Australia. So that select airports, you can get clearances to actually fly in controlled airspace. More recently, we went through the joy and fun of getting ISO 27001 certified for information security. And as we'll see, as one of the topics today about security, and one of the security things is information, and how important that's becoming going forward. And sort of what we're sort of doing today is really working on how do we automate those more complex operations, drone operations, so the beyond line of sight type of operations. So a lot of work happening in that space at the moment. But what I thought I'd start off with is really trying to show how drones actually reduce those safety risks at the moment. So I'll go through a few different examples, and maybe you've seen some of these, maybe you haven't. But this is one company out of Europe called Ilios. They make a drone that goes in confined spaces. So anyone who's worked in industry knows going into a pressure vessel or a boiler or anything like that is a lot of paperwork, a lot of tickets, just to make that happen. So actually putting in a robot to actually go do that. And this one's caged, so it can bounce off walls and do all those sorts of fun things. That's a huge safety reduction. There's another company, Skydio. So this is their drone doing bridge inspections. So basically it has 360 cameras. It builds up its environment visually and sort of autonomously navigates to a certain degree. So it's really good at going in those places where, normally someone would have to abseil, or someone would have to get a special scaffolding to get under bridges and things like that. They can sort of do that automatically. Another big success story out of Queensland is Emerson. So their unit to actually autonomously navigate underground, so in GPS denied environments, essentially using LiDAR and SLAM. All the way through to sort of working near hazardous emissions. So, this is everything from operating close to power lines. That drone in the middle there's got a methane sensor on it, so it's actually sensing, dangerous gases. And the one on the right there is actually a local company, 6 Arms, that do measurement, sort of live radio measurements for high-powered antennas and things like that. So you can actually, you don't have to turn the thing off to actually, do work. And then, as I sort of mentioned, what's sort of coming out is sort of the drone in the box system. So obviously the drone remotely controlled, but recharges itself. And a lot of those are being used in sort of perimeter security, internal security inside buildings, because the Skydio can work in GPS denied environments. So there's sort of all sorts of interesting applications on that. So that's kind of been the traditional, flying robots are sensing. They're not actually physically doing anything, which has been sort of the domain of, I guess, traditional robotics. But now we're starting to see that come in. So another local company, Infravision, another success story. They're building power lines with drones. So they've built their whole trailer winch force sensing system, because that's traditionally done with big helicopters, highly dangerous. So they're now doing that with drones. Another company's actually washing buildings with drones now. So literally putting a pressure washer on the drone and flying it around to eliminate, again, working at heights. We've seen a lot of the delivery in regards to wings, actually moving products around. And then there's some more interesting companies. This is another one out of Europe that are doing NDT with drones. So with a unique drone configuration that can actually physically touch objects and get measurements. Another interesting company, another one of our customers, Air Seeds. They plant trees, so literally firing out little seed pellets to plant trees. This is an interesting one I saw. It's called the Flying Dragon, and it's actually being used to actually turn valves. So, which is, it's pretty wild when you see it. And then all the way through to the flying cars. So this is a company out of New South Wales, AMSL. So their flying cars are actually going through testing at the moment, testing and certification. So it's all sort of, moving away from seeing things to actually doing stuff, which I think is really interesting. So that's all really cool. So what we don't want to happen is we're using all these drones to eliminate safety risks. How do we make sure we don't actually create new ones in that process? So this is particularly risks to other aircraft and risks to people on the ground. So what do we do about that? Well, the aviation regulators around the world sort of got together and said, this is a problem we need to solve. And this is what they came up with. It's called the Specific Operations Risk Assessment. And the reason I'm bringing it up here is some people in other fields may not be aware of it. I think it's an interesting framework, and it may be some ideas in here that you can borrow for different sort of domains, the land and water environment. So I'll give you a quick overview of how it works. So in essence, there's a bit of science behind this, but essentially you're coming up with a category on what's the risk to people on the ground for your flying drone operation. And then there's also what's the risk to things in the air. Depending on your risk level, you then have to put mitigations in place. So typically when you look at the ground, what are some of the mitigations you can do? Well, you can physically tether it, so it physically can't escape. A few of the newer things coming in are actually flight termination systems. So this actually sits on the battery, and it'll actually cut power to the drone, so it actually can't escape a predefined volume. Some other companies are doing Edge AI, so basically on the drone, processing the video feed to detect where people are and then automatically moving out of the way, so you're never flying over somebody. And then if all fails, there's the good old parachute that will automatically deploy and basically minimize that risk of causing damage on the ground. In terms of the air side of things, some of the mitigations that are in place at the moment is, so one element is called strategic mitigation. So this is some work done by Queensland University of Technology and Air Services, where they're actually quantifying what is the risk of you encountering another aircraft. And so they basically developed these maps. So black is you can't fly at all the way through, and then 50 feet increments up to 400 feet where you can fly. And that's based all on existing flight paths and tracks of aircraft. So that's at the strategic level. You can get a bit more tactical with the UTM system. So that's basically actively sort of managing separation between drones and other aircraft. So Air Services are working on that system, and that will sort of start to come into industry in the next year or so. So then you get into the questions of, okay, how do you track these things? So there's a whole range of trackers and things that are coming out now to try and track the drones. And then sort of the ultimate tactical mitigation is actually a detect and avoid system. So these are sort of actively sensing their area, whether it's ground-based or on the aircraft, what other aircraft are out there, and then moving to avoid them. So that's kind of the, at a very high level, sort of the air and ground risk. The other part to this process is actually then setting some operational safety objectives. So how that works is essentially you get your air and ground risk, and you kind of get this overall risk for the whole operation. That then leads into setting the thresholds for these different criteria, right? So these things called OSOs, and essentially, you know, they're everything from how is the device manufactured, all the way through to what is the operator's procedures, what training do they have, what software to use, how is that managed? So there's a whole range of them. And then you go into those, and then they have different levels of integrity and assurance you have to meet. So you can see that it's quite a robust framework. There's a fair bit involved in here, but you know, I think it gives people a lot of confidence that, you know, all the boxes are being ticked, and that, you know, everything's safe and compliant. So that's a sort of a really quick overview of what's around now. What are the future challenges coming? So one of the big ones is cyber. So again, the people at Jaris and who made Sora have actually come up with a specific annex related to cyber. And you know, there's a whole bunch of issues in cyber, and as we're seeing sort of in the Ukraine conflict, the whole jamming and spoofing, there's a bit of an arms race on at the moment. So no doubt, you know, things will come out of that which will affect industry going forward. The other big supply chain, the other cyber challenge is actually around the supply chain, right? So, and it's one of the reasons we went and got our ISO certification, to basically make sure we're not we're not the weakest link in that supply chain. So going beyond that, it's the integration. So currently everything's sort of separated. Drones are separated from traditional aviation to emerging aviation, as they call it. So how do you integrate those? And this is really going to come down to things like, you know, how do you assure the position of the drone, and how do you assure the performance of the drone? So, you know, there's assumptions that the drone can do certain things in certain time periods. How do you assure that? So that's just not on the reliability side, but also the maintenance side. Beyond that, when can the autonomy be unleashed, right? So these things are capable of being autonomous. When can you do that? And it's probably, how do you assure the autonomy? And I know a lot of work's been going on in this space. And again, the people at Jaris have actually come up with a initial methodology to try and evaluate the levels of autonomy for drone operations. So there's some work being done there. I think a couple of the other big ones is around social acceptance and the legal ramifications. So who's actually responsible once this thing's moving around without a sort of human sitting in the middle. And the other thing, I think the other interesting thing that comes up is overall safety and security. So what do I mean by that? So one of the examples we have in the electrical industry is, someone's got to drive 100 kilometers to go and inspect something, right? So there is a high risk that person driving out there, crashes and potentially is killed. We could replace that with a drone. And there is obviously risk associated with the drone, right? And say that's, the drone's got a 1 in a million chance of causing a fatality, but if you go on the car, you've got a 1 in 100,000 chance. So it's kind of like, while there is risk with the drone, there's actually more risk with the car. So, can we sort of justify that where it wouldn't normally be allowed in aviation? Because in aviation, it basically has like a 1 in a billion sort of risk level that you can actually, go ahead and do that operation. And obviously to do that, then you actually start needing experts across different domains, right? So this, I think, is one of the interesting things going forward. I don't know how long I've taken, but I think I've been long enough. If you want to get a hold of me, there's my contact details. And now I'll throw it back to Nathan.
Awesome. It's never long enough, man. And I also don't know how long you were because I was paying attention to what you were saying, not the clock. I feel like there's someone somewhere paying attention to that stuff. But hey, they're not invited, right?
Excellent.
It's really kind of interesting. I think our minds are in the same kind of place. Maybe the list just emerges a little bit different. So I think the cyber risks are probably the first thing that pops in my head because maybe, I don't know, they're a bit more sensational. But it seems like you started with the operational risk. I thought it was really interesting how you were talking about it's quite possible to mitigate a lot of the risks. There's a question coming, don't worry. I really feel like it was interesting about how you're almost blasé or just casual. It's like there's a sort of reality that robotics is going to come. There's a reality that distributed systems are going to come, and more autonomy and more, edge AI intelligence or teleops or something is going to come. You didn't even dive into whether that's a thing or not. It's like, okay, that's happened.
Yeah. So I don't know if we're doing questions now or you want to leave to the end. I'm easy.
Yeah, so I definitely have one, and since I've got the steering wheel, I reckon I'm going to go with it. Kerry, mate, I hope you're okay with that. So I'm just interested in your perspective. So is cyber the next big thing that needs to be solved? You mentioned safety by separation, but then you also mentioned social and legal repercussions. It's a bit chicken and eggy. Where do you start? What needs to happen first? What do you reckon?
Yeah, so I think what's traditionally happened is it's been a lot of the operational. It's like, can we do it? Which makes sense. So it's kind of proving up that on a very small scale. So typically it's kind of been isolated away from everybody, out of sort of harm's way, low risk, so to speak, to actually prove up the use cases. Now it's basically going, okay, we want to take that and scale that. What are the problems we're going to hit? So there's some people that are future thinking and can kind of see what's going to happen as soon as you start trying to scale this. So the conversation. So one thing I didn't mention in there is actually noise. So that's a big piece of work that's kind of happening in the background. Because once you have these things buzzing around everywhere, people are going to get pretty irritated, right? So it's how do you manage that? What are the technology solutions? Quieter propellers, all that sort of stuff. And so as part of that traffic management system, there is a component in there about noise management and aggregate noise. So, for example, if there's you wouldn't get an approval if, for example, in that same space, there's been, 3 flights there the same day, all within the same sort of time period, a cumulative noise would kick in and say, no, you can't go there during that time. So they are sort of thinking what these problems are going to be. It's not really a problem now because they just don't exist. But yes, you can totally see and it becoming a problem, and kind of the way the industry is, it's just generally taking it as a problem at a time. So it's like we go do it. Okay, what problems do we hit? Solve that. Move to the next. Okay, that's then going to cause that. Okay, we solve that. So that's rather than saying let's find the perfect solution first before we move. It is kind of a little bit the other way, where it's like let's just start small, simple, and kind of build up, which I think is a good approach. Otherwise, you end up doing nothing, right? You just get paralyzed.
So I think we're again on the same wavelength. It feels like a lot of robotics, the proof of concept, or the prototype of the first 1 or 2 is in the past. It's in the rear vision mirror. Like, okay, now that was doable some way,
Yep.
And the questions now become, right, let's scale it up and integrate it into the world. Yeah. And that's just brought on a whole bunch of different things.
Yeah. Sort of other issues.
Okay.
Yeah, exactly. And another one is privacy,
Sorry.
right? They didn't even talk about privacy, right? And that's another huge area.
In the spirit of trying to be polite, maybe we'll leave that topic alone because I've got some thoughts in there. Maybe Kerry, we better give you a crack to show us your slides and talk a bit about what UFR does, because I think we're going to end up descending into probably an interesting conversation, but the clock might be against us.
That's all right. I think I don't know if mine's going to simplify things anymore, but we'll give it a go. I think I can share my screen if everyone can see that. So I've already done the introduction, so I'll sort of skip ahead a little bit. But I guess in terms of how my background relates, all right, just navigate through here. So that's me out on site at a BHP site last year, with a whole different, with a nice little squad of robotics enthusiasts, to go and figure out sort of what the vibe is. And I say that from a very legal point of view, figuring out what is required on site, and how much resistance there would be, or what some of the drivers are around robotics, especially in an underground mine, such as Prominent Hill. So I guess I'll just jump straight into what my presentation really is about, is achieving safe mines, but also safe robots. David really already touched on some of these points, that bringing in robots into a mine is a great solution for a lot of risk assessment purposes, but they bring a whole swag of their own safety challenges. So I want to sort of explore the interconnected challenges that mine safety as well as robotic safety have, and sort of the interplay that they have with each other, as well as some of the challenges, opportunities, and risks. My overarching point, I guess, today centers on the idea that the pursuit of robotics within mining is still ultimately profit-driven. While robotics emerges as this key to unlocking, or the elimination of human vulnerabilities within a mining environment, we can also explore how robotics is unlocking hidden value by pushing past just the elimination of safety and now re-exploring these previous tasks, which were considered too dangerous for humans to attempt. All right, so we'll kick off with a very brief introduction. This is nowhere as detailed as what David was bringing, but this is base level, just risk assessment. So The goal in mining, eliminate hazards, create a hazard-free environment, prevent accidents, minimize injuries and fatalities, and ensure compliance with regulations. Ultimately, that seeks to build a strong safety culture, and we continually improve on that all the time. We take a very similar approach internally at UFR, and being responsible for that. We get a very close insight as to what some of the issues are, especially when we're prototyping machines, arise with safety in running these things in a base form, let alone rolling them out to an entirely foreign environment. So in pursuit of this goal of safety, we undertake countless, and so do the mines, countless amounts of risk assessment. And these are of paramount importance because they systematically identify and evaluate the potential hazards, and then allow us to be proactive in addressing those hazards. So we would argue, and obviously I'm biased, being a representative of a robotics company, that the best way to mitigate a risk through in the hierarchy of controls on the screen is elimination. And we see robotics as playing a very crucial part of that. Mines currently employ a whole different range of mitigation strategies depending on the situation. And despite all of the training procedures, safety equipment, management experience, accidents can and still do happen. People dying at work still happens. And in the context of something like underground gold mining, if it's not an immediate injury, long-term illnesses such as silicosis still lurk in the shadows, and can destroy someone's lives many, many years after they're exposed. So Queensland, tragically, at this point, records an average of 2.4 deaths per year, and around 80 to 100 serious accidents annually. Ultimately, safety does come at a cost. And so not all elimination of hazards is going to be practical, and it's certainly not a cheap task. So for a long time, mines have had to operate as businesses on the idea that no accident is 100% preventable, and that some degree of risk must be accepted in order to profitably operate. With robotics, we are seeking to change that. Hop to the next slide once I can get control of my mouse. Okay. So where does robotics sit in safety, especially within the mining industry? At UFR, we see our ultimate goal is to remove people from dangerous places on the work site. In a purely risk assessment focus, robots allow humans to complete tasks away from the dangers of a mine. It's currently the best method that we have to eliminate identified risks. So things such as rockfalls, cave-ins, explosions, gas leaks, fires, entrapment, and flooding, all very hazardous to human life, not at all hazardous to a robot. And we can, a simplistic way of approaching this. This is starting to delve into the territory of what we describe as zero entry mining. That is a mining process where we can completely remove any people without economically affecting the process of the site, or the output of the site. In those situations, at this point, it is largely hypothetical. Robotics is getting there. It would be an enormous task to redesign, and the concept has been floated at forums previously that I've attended, such as the Global Mining Guidelines, the GMG group. Sue Kay delivered a very excellent hypothetical situation, which highlights how we could be thinking about this process. And that's if you were to be creating a mine on the moon. So now we've removed the question of how we will protect humans, and it's changed into the question of how do we achieve this task in a environment where humans cannot be there. And that starts to generate some really interesting concepts, obviously, but at this point, largely hypothetical. So I will leave that, discussion for another time, and focus on more what UFR is focusing on at the moment, which is you've got sites that are operating currently, and we need to introduce robotics into that environment for safety purposes, or and what that looks like. So you have these brownfield sites. The implementation of automation robotics is really, as far as we see it, around retrofitting existing infrastructure with new technology. And this process can be really challenging because it requires a large amount of integration into the established environment. So we'll quickly talk about what some of those large challenges that we have to deal with every day are. So the basic one, you bring in a robot, it moves on its own. The interaction between robots and other pieces of equipment on site, or the actual infrastructure of the mine, as well as personnel, that's a huge risk. Navigational challenges. Underground mining environments are very complex. Uneven terrain, tunnels, obstacles. Bringing a piece of equipment to operate underground is crucial to avoid collisions and further accidents. Need to be able to respond to emergencies. Communication. This is becoming less of an issue, but we're finding that with a number of clients that we reach out to, that especially within the underground mines or very remote locations, that communication to support robotics is not sufficient. And so that's sort of, whether the technology catches up to the limited communication that we can be provided underground, or whether it's, infrastructure changes moving forward. That's also something that needs to be heavily considered. Touched on human-robot interaction. There's a lot of issues operating machinery around in an area where humans are. These are not small robots that we're looking at. These are often, large haul trucks, loaders, excavators, boggers. These things are as hazardous as they get in terms of equipment, and setting up, mitigation strategies for the danger of the robot is crucial. So that'll be collision avoidance systems on board the machine. That'll be autonomous operational zones. Laser tripwires, light curtains, anything to prevent anything from entering the same space as a robot. These are becoming, once again, there's a lot of work being done in this space to understand what the best approach to this is, and there's a lot of different ideas. Regulatory compliance is going to be a huge pain to overcome. Robotics doesn't fit neatly into the mold. It breaks a lot of the rules, and like David discussed before, there's going to be work to first prove up the concepts and then really start pushing the compliance side of it to make sure that the solutions we're coming up with are allowed to operate. Training competency. This is a very management level issue. We're trying to disrupt the way processes are happening on site, and the solution here is an immense amount of collaboration. Finding the people who will be your champions within a company, and understanding the skills that need to be developed over time in order to support your robotic, solution. So despite all of these challenges, they are manageable. It requires a lot of interaction with the customer to get them on board with a lot of potential changes you're going to make. And from a robotics level, and granted this might not my forte, I'm not an engineer, I'm very happy to flag any questions and give you more information. We'd love to hear from you and love to get you in touch with the marvelous engineers who sit behind the safety of our machines. But we work very closely with our customers to develop risk assessments, how introducing robotics into their operations would change their risk assessments. And then we spend a lot of time making sure we're complying with ISO standards. Functional safety is at the core of all of our software and hardware and how that comes together on a robotic platform. And ultimately, these things all need to be signed off and approved by our customers.
Kerry, just let me jump in for a second, mate.
Sure.
we need to move on and give Craig a chance to talk about something. So let's say 1 minute, okay?
Yep. Okay. So in how this all wraps up, the opportunities for robotics are not about a one-to-one replacement within the mining. We're finding that the best places for them are where we find tasks that were previously too dangerous for humans to undertake. I'll jump straight to our haul truck. So we've integrated on our haul truck. This is a 65-ton truck. Its operation is autonomous, but its core use case is to operate during shift closure after blasting has happened in the mine. So it'd be previously a completely hazardous environment for humans to enter, and we're now able to continue operations through that period, despite hazardous gases, dust, rock falls, etc., within the mine. So that little jump has allowed us to bring in autonomous features into a mine. It wasn't just a purely safety thing. It's now what we call unlocking the hidden value. This exists in a number of our platforms, and has been sort of the linchpin in bringing robotics to very established operating mine sites across Australia and around the world. So I'll leave it at that. Here's my contact details. We'd love to hear from you, and love to show you a bit more about some of the platforms and solutions that we're bringing to not only mines, but defense, ag, and in the construction industry. Thank you very much for having me, and I'll pass it back to you, Nathan.
Cool. So sorry to hit the pressure on you there, mate.
That's all right.
I think it's really, really interesting, right? So safer operations is a good motivator to get started. Safer robots, maybe inward speaking, is a necessity for them to exist. But then you have these malicious actors, you have safety, distributed systems. It just keeps getting bigger and bigger and bigger. I think the bit that resonated with me perhaps the most in your talk was we really need to do a reevaluation of everything, because perhaps the best way to use the robots is not from a direct replacement, it's from a fundamental change. And with that delightfully confusing segue, let's hand over to Craig. Craig, mate, if you can give us a couple of 30 seconds on who you are and what you do and why the world should be better, and then jump straight into your presentation, that would be awesome.
So my name is Craig Imrie. I work at PILZ. We specialise in machine safety. I'm part of the consulting group. So we do some consulting on sites for safety of machinery. We also run the PILZ training courses as well, if you want to get certified or learn things about machine safety as well. So today we just want to give a really brief talk about robots in industrial applications. So I want to show you two types of setups that we see. The first one is what we'd probably call traditional setup. Okay, now here you can see the robots are working. They're in a caged area. All the space around where the robot's moving is protected. The operators are on the outside, nice and safe behind the fence. If the operators need to get into here to do tasks, they'll go through access doors. There'll be a safety system to stop the robot so they can get access nice and safely, okay? And that's probably how we typically see robot applications done in industrial. Now, there's many things that you need to be concerned about with safety. I'll just show you a couple because we don't have a lot of time today. So one of the things that you have to think about is how you stop the robot from restarting when someone gets access. So this all comes to how you design your cell. So you've got an operator going in. He doesn't lock the safety system out in this instance. He's hidden from the other operator who then starts the machine, and then we have an incident, okay? So you got to think about how you incorporate your robot into the cell onto your factory to avoid things like that happening. Other things that you need to consider as well is what happens if the robot malfunctions or someone puts the wrong code in the robot. The robot has to be restricted in its movements, okay? So you can have a cell around the robot, but we have to ensure that the robot can't move outside of that cell, okay? So we don't want someone walking next to the fence and then the robot malfunctions, or we program it wrong and the robot goes through the fence and hits the guy. So anytime you're setting up an industrial or traditional application where you got a robot in a safeguarded area, you must constrain the movements of the robot to the appropriate reliability to ensure the robot can't move out of that area that you've protected. Now, another way that we're seeing robots being used is a little bit different these days. It's called collaborative applications. Okay. Now, this is where we actually have the humans and the robot doing a task together in the same workspace. So unlike we saw with the traditional, where you got a fenced area and the robot does its work and the humans are outside, in this video, you'll see, when we get through the introductions there, you'll see here, see the people are working in the same area as the robot. So they're putting some parts in this assembly, they initiate robot movement, and there's the robot moving. There's no fence, there's no nothing. There's human and robot interacting and moving in the same area. Now, of course, when you got a collaborative application like this one, now there's chances that you can have a collision between the robot and the human, unlike the traditional applications we saw before. So you have to think about the potential injury that a person could sustain from a collision and make sure that if there is a collision or a crush event, you're not going to injure the person. So, you know, to show you an extreme example of that, we've got a video here. What do you think about this? Do you think that this is okay to have the human and robot working in the same area if this was our collision event? Okay, probably not. Okay, there's a lot of energy in that collision, right? The robot's moving in a path that hits the person in the face, not what we'd want for a collaborative. It's moving very fast. It's got a lot of weight. There's a lot of energy there. So this is going to cause significant injury, okay? So we have to avoid injuries like that, of course, at the extreme level, that one I showed you. But we have to avoid injuries like that when we're going to do collaborative applications, where we might get potential collision or crushing events between the robot and the human. So what are we going to think about when we're creating a collaborative application and making sure that we're controlling the risk of these events? We need to make sure that the forces, pressures, and energy around a collision event or a crushing event between the robot and the human are under an acceptable threshold, okay? So if we're under here, we probably won't cause injury. But if the forces or pressures go above this, we might cause injury. So you've got to make sure that you design your application to ensure that this is the case. And the things that you're going to have to consider is how fast you allow the robot to move. Okay, the quicker the robot moves, the more energy. Yeah, the effective mass of the robot, okay, including its payload. Okay, so that's going to affect the amount of energy in a collision as well. The surface area. You'll see a lot of these robots that are used in collaborative applications have exaggerated surfaces to increase the surface area of the contact to reduce pressure, okay? You also need to think about the path of the robot's travel. So you don't want it traveling, say, at head height. And different parts of the body will have different spring constants. If you've got lots of meat or muscle tissue in a certain area of your body, you generally can absorb force better than bony areas like your hands and your fingers. And then we also have to think about force thresholds of the robot as well. So all these things have to be considered or calibrated properly. And then we test our robot application. Here you can see here, this is a testing device here. We're going to crush the robot down onto that. That device will measure the force, plot it on a graph, and then we can prove that this has been calibrated correctly and the forces of a crushing event are low enough that they won't cause injury. So there's a bit of work there to do in collaborative applications. I just want to stress one thing. A lot of people buy a collaborative robot, which doesn't really exist, out of the box and think it's just safe. When you buy a collaborative robot, it has the ability to do this correctly, but it needs to be calibrated for your application. So it's going to depend what end effector you're using, the weight of the product that you're carrying, how quickly you allow the robot to move, the path that you take the robot and what parts of the body we expect contact to be, and the force thresholds that you put into the robot. It needs to be calibrated and then tested. Okay, so there's a bit of work there to ensure that the risk is controlled with collaborative applications. So We looked at traditional robots, collaborative robots. We see that there's some considerations, and I've only shown you the main ones. There's many other considerations you have to think about for safety. What process should we be following to ensure that we've considered these and implemented the correct measures and implemented those measures correctly? For any machine safety application, we use the same process, and it's the same process that we use in robotics as well. First, you need to do a risk assessment. You have to understand what the hazards are, how people are going to interact with the robot, and estimate the risk of those interactions. Then you have to select the appropriate risk reduction measures, be it guarding, admin procedures, PPE, safety systems, whatever we are going to use. Then this is a very important step that doesn't get done very well in a lot of cases. You need to define the requirements of your measures that you want to use to reduce risk. Okay, so you have to define the requirements of your guarding system. You have to define the requirements of your admin procedures, and you have to define the requirements of your safety systems. If you're using safety systems, there's a common document. If you've done work in this area, you might be familiar with Safety Requirement Specification, SRS document. They will explain exactly what the safety system needs to do, how reliable it needs to be. Once we've clearly defined the requirements of all the measures that we're using, then we can get someone to design those safety measures in place. Now, important at this step, you get someone independent to verify or check or evaluate, whatever word you want to use, that the design is correct. So you give them the design documents, the specification documents, which have all your requirements in there, and the person can validate or verify that the design meets the requirements as set out. Once the design has been checked and we say, yes, that's correct, it's a good design, we can install our measures, and then you need to get someone independent once again to come in and what we call validate. So inspect it, check it's been installed correctly, and test all your systems. Okay, and ensure that they're actually working the way that we intended. If you follow these steps, then you'll be controlling the relevant hazards, you'll be selecting the correct measures to reduce the risk, and you'll be proving that those measures are performing the risk reduction that we want it to perform. Okay. You need competent people to be doing these steps because, of course, the risk reduction is going to depend on how well the people carry out these activities. But if these activities are done correctly, you'll end up with a safe application. Now, just quickly, if you're doing work in this area, some standards that you need to be familiar with. 40243301, this is the standard that the robot needs to achieve. So if you want to use a robot in industrial applications, it needs to be designed to that standard. Of course, most robots come from overseas, so the equivalent international standard is this one. Okay, that's the ISO standard there. So that's the robot. Now, as I showed you with that unexpected startup video, it's very important how we design the environment that our robot goes into. Yeah, how we design our guarding, how we restrict the movement of the robot, how we allow people to restart when someone's gone into the cell. All of those aspects are in this standard here, 4024.3302. That will tell you how to design your robot application, whether it's a traditional or a collaborative. Okay, and then we've got this standard here for the collaborative robots, 4024.3303. Remember I showed you here, there's certain rules on what forces and energies and pressures we're allowed to have at a collision event. All of those thresholds are explained in that 3303 standard. It also explains a little bit of how you can do testing and what you need to test for your collaborative applications. So that standard's a useful one there when you're trying to prove that your robot in a collaborative application is safe and is proven. Okay. And that's it. So thanks for your attention. I'll hand it back.
Too easy, Craig. And the first thing I want to do for everyone is violently echo how important what you're saying is. I'll give one very simple example because I see mistakes all the time, and I'm sure Craig sees an order of magnitude more mistakes than I do. But one I see all the time is someone buys a collaborative robot and goes, okay, problem solved, it's safe. And maybe they put in a little bit more thought, and if you get a hit from it, they go, oh, that's going to hurt, but I'll survive it. But very rarely they put in a thought of, oh, but that might make me take 2 steps backwards and then I'll fall off the balcony. And those kind of unexpected things, and I think is when you really need to call in the experts, because they really have this holistic lens of not just the robot, not just the safety buzzword feature that you bought it for, but the whole environment, the whole system, the whole architecture. And I find it vital. Sorry to commandeer that so much, but I just really wanted to tell everyone that I think it's really worth just picking up the phone and saying to someone, hey, you do this all the time. Can you have a look and tell us what you think?
Yeah, that's right. Yeah, the collaborative robot doesn't understand the full limits of the application, because it doesn't. Sometimes you might be using a different end effector. It doesn't know what the payload is, doesn't know what the mass is, and then a lot of the features in there allow you to make the collaborative application safe, but you have to set them appropriately, like speed and force thresholds. And until you test it, you don't know if it's actually under those thresholds as dictated in the 3303. So think about those robots as they have the ability to be used in collaborative, but they need to be set up correctly. They don't just come out of the box safe.
Absolutely, definitely. I think everyone, but not just you, Craig, but Kerry and David as well, I think everyone's said some pretty interesting stuff. And I certainly have some follow-on thoughts or ideas or wants, and I'm sure the rest of the audience does as well. So Nikki, is it okay if we go through you, send maybe an email, can you connect us with such and such about something?
Yes, of course. It's nikki.rousseau@roboosnet.com.au. I said that very quickly. It will be at the end of this webinar, everyone's contact details anyway. I'm assuming, guys, just a hands up, I can put your email addresses there. David, Kerry, Craig, all good? Fine. I'll put it at the last slide of this presentation. Everyone's contact details will be there. Yep.
Okay, I think I've pretty much said enough. I just really want to thank everyone, all the panelists. You guys are pretty interesting, and I'm sorry for being too interested and wanting to talk too much. Maybe I'll stop and we'll let Nikki have the final word.
Thanks, Nathan, for your expert moderation. David, Kerry, and Craig, thank you so much for joining and making time available in your schedules. I know you're all very busy. To all our participants, thank you very much for joining us. Our next webinar will be on bushfire mitigation on the 28th of February. The link will be available in the coming days on our website, and we'll also advertise it. And we've got a whole host of webinars that we'll put out for the rest of the year, generally speaking, the last Wednesday of the month. So with that, I know everyone's probably dying to have some lunch. Have a fabulous day wherever you are in the world listening to this, and thanks for joining us.
Thanks, everyone.
Thanks, everybody.
Thank you. Thanks. Thank you.